Welcome to Mastering Solutions. This question is one of those really frustrating questions where, as a student, it doesn't make sense and it's really hard to understand how to approach the problem. But once you understand it, it's actually a really fun question to work through, and it's kind of a cool concept to think about. To start it, we want to use the magnification equation, which says that magnification is equal to the height of the image over the object height. And that's also equal to the negative image distance over the object distance. And so if you think about the question, looking at the picture, we see the hand that's on the top right. And that is the actual hand, him holding it up in front of the camera to take the picture. The one that's on the bottom left, that is the image of his hand. And you can see the image of him in the rest of the photo, right? And so what we need to find is how far away did he put his hand from the mirror. So we're trying to solve for the object distance. That's our whole goal. And now the hands, they're about the same size, right? So that means that magnification is going to be 1. Now they're inverted from each other, so it's going to be a -1. And so a -1 for magnification, again, means that they're the same size and the image is inverted. So we're going to set this magnification equal to the object and image distance. So -1 is equal to -s prime over s. Since both of them have a negative, we can multiply it by -1 to cancel that out, or you can think of it like we're just canceling that, right? So now we have 1 is equal to the image distance over the object distance. And now if we multiply both sides of the equation by s over 1, or s, now we have the object distance is equal to the image distance. So this relationship is really important for this question. Now what we're going to do is we're going to use the thin lens equation, which is 1 over the focal length is equal to 1 over the image distance plus 1 over the object distance. And we're going to plug this in for s, because remember, s is what we're trying to solve for. And so now we have 1 over the focal length is equal to 1 over the object distance plus 1 over the object distance. We have two fractions, and don't treat this like multiplication. Remember, we're adding fractions. So what we're going to have is 1 over the focal length is equal to 2 over s. So now we want to solve this for s. So what we can do is let's first multiply both sides by f. And if we come over here, now we have 1 is equal to 2f over s. And now we can multiply both sides by s. And so we finally have s is equal to 2 times the focal length. So this here is our answer. Because I said we want to express the distance in terms of f. So what this tells us and what we've figured out is that this will give us a real inverted image at the same distance, and we want it 2 times the focal length.